In the early hours of July 26, as the city of Stavropol in Russia's Stavropol Krai remained shrouded in the dim haze of dawn, an invisible force quietly infiltrated the airspace. Ukrainian unmanned aerial vehicles, UAVs, directed by Ukraine's Security Service, SBU, carried the power of modern technology and unyielding resolve, heading toward a critical target, the signal plant, a key facility in Russia's military-industrial complex. These UAVs, launched from mobile platforms concealed in the shadows, moved with deadly precision, exploiting the cover of night and terrain to evade Russian air defense systems. This facility serves as the hub for producing electronic jamming systems such as Smalta, Gardenia, and Topol-E, along with radar and radio navigation equipment, playing an essential role in Russia's military strategy. The strike not only aimed to destroy physical infrastructure, but also served as a strategic declaration, affirming Ukraine's capability to penetrate deep into Russian rear areas, more than 217 miles from the front lines. The signal plant, located in the southwestern industrial zone of Stavropol, is protected by a stringent security network, including NABO-M radar systems and Pantsir SA-22 air defense units, making it a challenging yet high-value strategic target. At a secret base in Ukraine's eastern Kharkiv Oblast, over 248 miles from the Russian border, SBU specialists worked tirelessly for weeks to prepare the operation. The signal plant in Stavropol was identified as a priority target due to its critical role in Russia's military supply chain. The facility produces electronic jamming systems like Smalta, jamming range of 31 miles, power output of 1 kilowatt, weight of 441 pounds, operating frequency of 2 to 18 gigahertz. Gardenia, range of 25 miles, weight of 397 pounds, frequency of 1 to 12 gigahertz. And Topol-E, mobile jamming system, range of 19 miles, weight of 331 pounds, frequency of 3 to 15 gigahertz, as well as radar and radio navigation devices for Russian forces. Additionally, the plant manufactures high-precision directional antennas with 0.1-degree accuracy and remote control systems for armored vehicles with an annual output of up to 1,500 units. These devices enable Russia to maintain an edge in electronic warfare, jamming Ukrainian UAVs and missiles. Neutralizing the plant would deliver a severe blow to the production and deployment of these systems. The preparation process began with intelligence gathering. Ukrainian operatives, combined with satellite data provided by Western allies such as the United States and Germany, constructed a detailed 3D map of the signal plant. They identified two primary targets: Building 1, housing the radio electronic equipment production workshop, and Building 2, Workshop 5, containing computer numerical control (CNC) machines imported from China and Europe with 0.004-inch precision, valued at millions of dollars. These CNC machines form the plant's lifeline, enabling mass production of electronic components for military systems. In addition, auxiliary areas such as component warehouses, radar towers, and internal communication systems were marked for strikes to maximize disruption. Intelligence also pinpointed the plant's night shift schedule, with about 50 workers and 20 security personnel present at the time of the attack, along with a 360-degree camera surveillance system covering the area. The SBU opted for a combined UAV formation consisting of 12 units, 6 AN-196 Liutyi and 6 modified mini-Shahed UAVs. The AN-196 Liutyi, produced by Ukroboronprom, measures 11.5 feet in length with a 23-foot wingspan, speed of 93 to 124 miles per hour, maximum range of 621 miles, 110-pound explosive warhead, GPS INS guidance system with less than 16-foot accuracy, and infrared sensors for low-light target identification. The mini-Shahed UAV, based on Iran's Shahed 136 design, has a length of 11.5 feet, wingspan of 8.2 feet, speed of 112 miles per hour, range of 497 to 621 miles, warhead of 66 to 88 pounds, with remote control via encrypted 5.8 GHz frequency, optimized to overcome Russian jamming systems. Some intelligence sources suggested the potential use of a mysterious jet-powered UAV, featuring a WS-140B turbine engine, speed of 249 to 311 miles per hour, range of 311 miles, and stealth wing design, but this information remains unconfirmed officially. The attack plan was built on three principles: precision, synchronization, and stealth. The UAVs would launch from a base near the border, fly at low altitude, 656 to 984 feet, to avoid Russian radars, and strike the two main buildings of the plant simultaneously at 4 a.m. on July 26, when visibility was low and Russian air defenses were less alert. To ensure success, the SBU conducted simulation tests at a training area in Ukraine, using replicas of Russian air defense systems like the Pantsir SA-22, engagement range of 12 miles, firing rate of 5,000 rounds per minute, radar frequency of 10 to 20 gigahertz. The test showed the AN-196 had an 80% survival rate at low altitude, while the mini-Shahed could overload radars through swarm attacks. The simulations also included failure scenarios, such as GPS signal loss or detection by Russian radars, with contingencies like switching to inertial navigation or altering flight formations. At 1 a.m. on July 26, at the secret base in Kharkiv, SBU technicians began preparing the UAV formation. Each AN-196 underwent thorough checks, from navigation systems to the 110-pound explosive warheads, programmed to target specific coordinates. 3 aimed at Building 1, 3 at Building 2. The mini-Shahed UAVs, with 88-pound warheads, were programmed to hit auxiliary areas, such as radar towers, fuel depots, and parking lots, to distract Russian air defenses. All UAVs were painted matte black, reducing visual detection in the dark. Each was fitted with radar-absorbent coatings, lowering the radar cross-section to under 1.08 square feet, enhancing stealth against Nebo-M radars. By 1:30 a.m., the 12 UAVs were launched from mobile platforms, using electric starters to minimize noise. The formation flew in a V-shape, with AN-196 at the center and mini-Shahed on the flanks, maintaining an altitude of 984 feet to evade ground radars. The GPS/INS navigation systems were activated, with preloaded target coordinates. A control team in Kharkiv monitored via encrypted Starlink channels, tracking data from UAV sensors, including speed, altitude, and battery status. An electronic reconnaissance team simultaneously monitored Russian radar signals from stations in Rostov and Krasnodar, ready to adjust flight paths if tracking was detected. The reconnaissance team used real-time signal analysis software, detecting any radar frequencies exceeding 10 GHz and relaying flight adjustments via Starlink within 3 seconds. The UAV formation's 217-mile journey lasted over 2 hours at an average speed of 112 miles per hour. To avoid the NEBO-M radar, detection range of 373 miles, frequency of 0.13 GHz, on Stavropol's outskirts, the UAVs were programmed to fly through remote rural areas using hilly and forested terrain to mask radar signatures. At 62 miles from the target, 2 mini-Shahed activated electronic jamming mode, emitting noise on the 1.2 GHz band, blinding the NEBO-M radar for several minutes. This allowed the formation to bypass the danger zone and enter Stavropol's airspace. During this phase, a secondary Russian radar station in Tatarka village unexpectedly activated, forcing the UAVs to descend to 492 feet and switch to an arcing flight path to avoid detection. At 4:02 a.m., as dawn's first light appeared over Stavropol's sky, the 12 UAV formation positioned above the signal plant. From 984 feet altitude, the infrared sensors on the AN-196 and mini-Shahed captured detailed images of the facility. Sturdy concrete buildings, industrial smokestacks, radar towers, and component warehouses scattered across a 25-acre area. The nearby Yuzhny market remained quiet, with only a few early workers starting their day. The plant's security force, comprising about 20 guards and a Panzer SA-22 unit, appeared unaware of the approaching threat. Infrared imagery showed Building 1's surface temperature at 77 degrees Fahrenheit, while the CNC machines in Workshop 5 emitted 104 degrees Fahrenheit, aiding the UAVs in precise target confirmation. The UAV formation split into 3 attack groups, each executing distinct tasks to maximize damage. The first group, consisting of 3 AN-196 L1, L2, L3, targeted Building 1, where Smalta and Gardenia systems were assembled. The second group, with 3 AN-196 L4, L5, L6, focused on Building 2, Workshop 5, housing imported CNC machines. The third group, comprising 6 mini-Shahed, SO1 to SO6, conducted dispersed strikes on auxiliary areas to disrupt air defenses. At Building 1, a reinforced concrete structure with a 4-inch thick steel roof, Smalta and Gardenia systems were assembled on automated lines. The lead AN-196 L01 dove at a 45-degree angle, speed of 112 miles per hour. The 110-pound explosive warhead detonated 6.6 feet from the roof, creating a powerful blast with a 49-foot destruction radius. The explosion breached the roof, destroying 2 production lines and incinerating internal circuit boards. Flames erupted from flammable materials like plastics and lubricants, producing black smoke columns tens of feet high, visible from the Yuzhny market 0.6 miles away. The initial blast triggered the building's fire alarm, but the automatic sprinkler system failed due to power loss, allowing the fire to spread rapidly. The LO2, following just 5 seconds later, targeted Building 1's eastern wall, housing CNC machines and component storage. The 110-pound warhead exploded, breaching a section of the concrete wall and exposing production equipment inside. Debris from the blast scattered across the area, damaging machinery and disrupting electrical systems. The fire spread to the storage area, causing secondary explosions as flammable components ignited. Smoke and dust enveloped the building, creating a haze that hindered security forces' assessment. Sharp metal fragments from the explosion damaged fiber optic cables, severing internal communications. The LO-3, delivering the final strike on Building 1, targeted the western wall, containing control rooms and server systems. The 110-pound warhead's explosion collapsed part of the structure, destroying production line servers and damaging ventilation systems. Temperatures from the blaze quickly exceeded 1,472 degrees Fahrenheit, melting sensitive electronic components, including chips and sensors for Smalta systems. The destroyed servers included digital design databases for Smalta, disrupting short-term reproduction capabilities. By 4:05 a.m., Building 1 had become a chaotic ruin, with black smoke rising and remaining workers fleeing in disarray. Simultaneously, at Building 2 housing imported CNC machines, the second AN-196 group initiated the assault. Workshop 5, spanning 21,528 square feet, served as the center for precision components for Topol-E systems and military radars. The LO-4 plunged directly into the workshop's center at 112 miles per hour, with the 110-pound warhead exploding over an area containing 3 CNC machines, each valued at $2 million. The blast created a 9.8-foot-deep crater, completely destroying the CNC machines and damaging the main electrical system. Metal debris scattered throughout the workshop, further impairing auxiliary equipment like 3D printers and assembly robots. The explosion also compromised the CNC machine's liquid cooling systems, causing hazardous chemical leaks that slowed on-site rescue efforts. The LO-5 targeted the component storage area, holding thousands of chips and sensors imported from China. The 110-pound warhead exploded, collapsing part of the roof and incinerating hundreds of component crates. The fire spread rapidly, fueled by industrial chemicals used in production, generating an intense blaze reaching 1,832 degrees Fahrenheit. Workers on the night shift in Workshop 5 panicked and sought emergency exits, but some became trapped by thick smoke. Toxic fumes from burning chemicals impaired breathing, forcing rescue teams to use gas masks for access. The L-06, delivering the final strike on Workshop 5, targeted the final assembly area, where components were integrated into finished products. The 110-pound warhead's explosion destroyed 2 assembly tables and damaged the automated conveyor system. Several electronic devices, including controllers for Topol-E systems, were completely incinerated. This blast also obliterated a technical drawing storage depot, complicating production line reconstruction due to lost reference materials. By 4:07 a.m., Workshop 5 was nearly neutralized, with smoke and flames engulfing the entire area, halting production entirely. While the AN-196 focused on primary targets, the 6 mini-Shahed executed dispersed strikes to confuse air defenses and inflict secondary damage. S-01 and S-02 targeted the plant's main radar tower, standing 49 feet tall, used for internal communications and security monitoring. 2 88-pound warheads detonated simultaneously, toppling the tower and destroying antennas, severing communications between plant sections. The explosion generated a large dust cloud, reducing visibility for security forces. The tower's collapse disrupted camera surveillance systems, preventing central monitoring of the entire area. S-3 and S-04 struck the fuel depot containing diesel and industrial chemicals. 2 consecutive explosions ignited a small fire with flames reaching 16 feet, but on-site firefighters quickly extinguished it before it spread. However, the attack destroyed part of the depot, disrupting fuel supplies for the plant's backup generators. The generators, designed to sustain operations during power outages, ran for only 30 minutes before depleting fuel, paralyzing auxiliary systems. S-88 targeted the parking area, housing trucks for component transport. The 88-pound warhead exploded, destroying 3 trucks and damaging others. While not causing major material loss, this strike disrupted the plant's internal supply chain, stalling component transport for days. The destroyed trucks held completed components ready for delivery to Russian military units in Rostov, delaying Topol-E system deployments on the battlefield. S-06 was programmed as a decoy to draw air defense attention. When downed by the Pantsir Sa-22, it fulfilled its role, distracting defenses and allowing other UAVs to strike unimpeded. The interception of S-06 expended 12 rounds of 30mm ammunition from the Pantsir, depleting available munitions and creating a 15-second window for the remaining UAVs to approach targets. Russia's air defense systems, primarily relying on the nearby Pantsir S-22 unit, responded belatedly. The Pantsir, equipped with target-tracking radar and 30mm cannons, only detected the UAV formation after it entered Stavropol airspace. Alarms sounded at 4:04 a.m., but the Pantsir radar was jammed by signals from the mini-Shahed, reducing detection effectiveness. Only one mini-Shahed, S-06, was downed, while the others completed their missions before Russian radars could lock on. The delayed response stemmed partly from the night shift crew of just 5 operators, insufficient to handle multiple small, low radar signature targets simultaneously. Encrypted Starlink channels transmitted data back to base, while electronic reconnaissance monitored Russian responses. By 5:30 a.m., as Russian air defenses deployed additional radars and patrol aircraft, no traces of the UAV formation remained. The SBU declared the mission accomplished, with 90% of planned targets destroyed. Starlink data indicated Russian communications were disrupted for 20 minutes post-attack due to the collapsed radar tower and internal systems. The strike on the signal plant achieved key objectives. Building 1 sustained severe damage, with 2 production lines for Smalta and Gardenia systems completely destroyed. Control servers and electronic components were incinerated, halting production for at least 3 to 6 months. At Workshop 5, 3 imported CNC machines were obliterated, inflicting estimated financial losses of $10 million, excluding replacement costs amid international sanctions. The Topol-E systems used to jam Ukrainian UAVs and missiles were heavily impacted, diminishing Russian battlefield defenses. This damage compelled Russia to seek unreliable import sources, increasing costs and reconstruction timelines. The psychological impact of the strike was substantial. Hundreds of locals at the Yuzhny market witnessed black smoke and heard explosions, fostering unease in the community. Videos and images from Telegram channel Exelanova Plus and X posts spread rapidly, symbolizing Ukraine's long-range strike capabilities. These visuals not only eroded Russian confidence in air defenses, but also bolstered support from Ukrainian allies. Some ex-posts from Ukrainian accounts garnered over 100,000 views within 24 hours, with comments praising the operation's precision and audacity. On the Russian side, the Stavropol governor claimed the UAVs were downed with insignificant damage. However, independent sources like Liga.net and Euromaidan Press confirmed severe damage to the two main buildings, with production equipment destroyed. Russia may need to redirect resources for repairs, while bolstering defenses at other industrial sites, dispersing forces. Reports from Liga.net indicated Russia redeployed 2 additional air defense units from Rostov to Stavropol on July 26, weakening defenses elsewhere. The assault on the signal plant marks a milestone in Ukraine's UAV strategy. It demonstrates remarkable advancements in UAV technology, from the AN-196 Liutyi to the mini-Shahed, and the SBU's complex coordination capabilities. The combined precision and swarm tactics overcame Russian air defenses, which proved ineffective against small, fast targets. Targeting military-industrial facilities like Signal signifies a shift in Ukrainian strategy, from degrading logistics to dismantling production capacity. In the context of the Russia-Ukraine conflict, this strike represents not just a tactical victory, but a strategic statement. It affirms Ukraine's ability to extend the fight deep into Russian territory, shattering the adversary's sense of security. With support from allies like Germany, donating 500 AN-196 units, and the development of new UAVs, Ukraine is reshaping the battlefield in ways Russia struggles to anticipate. The operation's success has spurred internal NATO discussions on enhancing UAV support for Ukraine, with Germany pledging an additional 200 AN-196 by late 2025. From meticulous preparation and synchronized execution to dramatic developments and safe withdrawal, Ukraine has proven itself not merely a defensive force, but a formidable offensive contender. The signal plant, with its wrecked machinery and rising black smoke, stands as testament to the power of these invisible swarms in the shadows.